Can you guys hear me in the back? Raise your hands if you can't hear me. All right. just checking whether you're paying attention. All right, so some announcements. Project 1 has been released, as you guys have seen on Piazza, hopefully. So if you guys did not get the email, that means that you guys should probably try to find our Piazza and get enrolled on it. Project 1 is released. We will be exploring population in the entire world and looking at how that changes over time. The checkpoint, which is the first 8 questions of the project, is due on Tuesday of next week at midnight. It is graded on completion, not correctness. So we're just trying to make sure you guys are getting started on the project, because if you guys wait until the actual deadline, which is next Friday, to turn it in, you guys are gonna have a bad time. Okay, so it's pretty long, challenging. Please start early, because otherwise you're going to go into office hours and there'll be like 20 people at office hours. So you want to get started as soon as possible, especially if you feel like you're not like super sure about the material or how like you understand what's going on in the class. You want to start as early as possible so you can get help when you need to get help. Okay? I also want to point out that the demos from the lecture are available online. Shout out to the student who told me about that yesterday. She's not here today. But if you go onto data8.org/summer17 and refresh, okay. Puzzling. Did I not push? Well, if they're not online now, they should be. Oops. They should be online. Why is it not changing? Okay, well, they're not online now, looks like. I'll figure out why that's happening. But when I do have them online, there should be another column here called lecture, and there'll be like a link that looks like slides, video, and demo. If you click on the demo link, you can get the notebook that I used during lecture for that class. So whatever I typed in during class, if you want to get that notebook, you can click on that link to get that notebook. Okay. I'll show you something that does work. So let's go to the textbook. If you go browse the textbook, you may notice that there are, let's say you're looking at my lecture on overlaying graphs. Okay, so here we have that. I can get rid of that. So blah, blah, blah. Okay, cool. Look, you want to take a look at this notebook. You can just click on interact here, and that will pull in the notebook into your server. Very convenient. Okay, so if you're looking at the textbook and you want to grab this, because these are all notebooks as well. If you want to grab this notebook and play around with the data yourself, or kind of go through what we did during class, you can just click that and get that notebook. So a couple of different ways of getting the stuff that we do during class. I just want to make sure you're aware of what's going on here. Cool. All right, what else do I have? I also wanted to remind you that there is an attendance excuse form. So as you remember, you need to get 4 hours out of 6 hours every week to get attendance. So today I'm going to be taking attendance twice, so you get 2 hours for today. If you cannot make a lecture for whatever reason, like an unforeseen circumstance, but you still want to get credit for it, there is a way to get credit for it. You just go to the links and click on the attendance excuse form and fill it out. Okay, so if you're sick or like you have a job interview or whatever, like go ahead and click that. You can get excused for attendance. It's all good. Yes, question.
So I tried getting to the form yesterday.
The form is not accepting responses. Let's take a look. Puzzling. You might have to view it with your berkeley.edu. So let's see. Let's try if I use my Berkeley edu. And then run the link, go to the link. Huh. Looks like I can't get it either. All right, I'll make a note to myself to fix that. Fix attendance excuse. Oh, all my announcements are just breaking today. Wonderful, it's a Friday. Fix attendance excuse form. All right, so when that gets fixed, I will post on Piazza and let you guys know about it. Okay, so sorry that it's been broken. What else do I got? Hopefully nothing else broken. Oh yes, this can't break. We have no lab on Monday. Oh yes, Alan.
All right, so the same time I cannot open the project.
It seems like you cannot open the project.
It says either file for timeout.
A timeout error, huh? Okay. Now that is also problematic. I wonder if I will be able to do it. We'll see what happens when I try to do my lecture today. If not, I can just run my notebook on my own computer. Okay. So there's no lab on Monday and Tuesday, but there is lecture on Monday, and there are office hours only on Monday, unfortunately. So if you want to help for your project checkpoint, you need to come in on Monday, because we won't have anything on Tuesday. Okay. Any questions about that? All right, well, it's Friday. The drilling has resumed. It's early in the morning, and everything is broken. What else could go wrong? Well, the data of the day says that as the murder rate in the US went down, or as the Internet Explorer market share in the US went down, so did the murder rate. Hopefully we know enough in this class by now to know that this is probably, like, the murder rate in the US is probably not caused or affected by the Internet Explorer market share, although you could certainly investigate it more if you would like to take a look. We'll actually be looking at the murder rate and the death penalty in Project 2. But that's kind of a long ways from now. But just keep it in your minds. We'll be looking at kind of this sort of data without the Internet Explorer part. Okay. All right. So I wanted to talk about what I could not cover yesterday, which was using apply with multiple arguments. Okay. Before I get started with talking about that, I want to kind of point out something at this point in the course. So at this point in the course, we're covering a lot of content at a really fast pace. Okay, and if you have never programmed before, this will all feel probably like very overwhelming to you, because it is kind of overwhelming. There's a lot of new ideas. First, you need to learn how to think differently in order to program. You need to figure out like what steps you need to take, and then you actually need to write down the code and make sure you don't make any mistakes writing the code. There's a lot of new stuff going on, and I understand that during lecture I also have to go kind of fast because I do have like the time constraint that I have, and so it's understandable to me. Like, it's totally fine if during lecture you're like, what is going on? I have no idea what code Sam is typing. That sort of thing is completely natural, and I'll try to go slower and explain myself more. But sometimes I just need to cover content because we just don't have a lot of time in this class, and we have to go double pace. Okay, so I'll try my best to explain myself more clearly. But chances are that even though I'll try, chances are that you'll still find that, oh, I don't really understand what's going on here. So my point to you, the point that I want to make to you is that it's okay if you don't understand everything that's happening during lecture. What's important is that you kind of understand what's possible. Okay, so what kinds of questions can you answer with the tools that we're learning in this class? Once you understand the kinds of questions you can answer, today we're going to be talking about grouping, which is a whole other kind of like its own ordeal. Once you understand like these different tools, you have to really kind of, when we go over these tools in class, you really have to understand what the tools are useful for. Okay, so don't concern yourself too much with exactly the syntax of how everything gets put together. Don't concern yourself too much with like the order of the arguments and like the nitty-gritty details. During lecture, if you're having trouble keeping up, just try to focus on what kinds of questions can I answer with these tools, okay? Because when you're actually working on your assignments and when you're actually taking our exams in this class, you will have access to reference, you will be able to reference everything that we've covered in this class. All the methods, what they do, how to call them, all that stuff you will have at your disposal anytime you're working on stuff for this class. If you're working on a lab, you can always just check the internet or check the textbook. On the midterm, we'll provide like reference sheets for you, as you guys have seen on the resources page. Okay, so again, this lecture in particular, the lectures today in particular are pretty nuanced and difficult. Okay, so brace yourselves, and I want you to keep in mind that just get the big picture. Okay, so don't focus too much on like arguments, like, because we'll look at methods today that have like 4 arguments. Okay, so don't worry too much about the arguments. Just focus on what kinds of questions I can answer with these tools. With that in mind, let's start on our first difficult topic. Okay, so apply using multiple arguments. Now, if you remember from yesterday, we talked about apply. So we learned about functions, and then we learned that we can use a method table.apply to call the function on every value in the table's column. Okay? And the way it works is we pass in the function to apply, and then we pass in the input column and columns. Now, yesterday, we just looked at functions that take in one argument. Okay, so we have a function. It takes in one number, let's say, and converts that number from Fahrenheit to Celsius, from Celsius to Fahrenheit, or Fahrenheit to Celsius. That's one type. That's one example of us using apply. Another example of us using apply was when we were looking at the movie sales. Remember? If you remember from yesterday, the movie sales, we did like this thing that took the min of that number and 1 billion. So if it's above 1 billion, the function will return 1 billion. So what we've done there is taking a number, output a single number. Okay? So that's what we looked at yesterday. Today, what I'm going to show you is that we can use apply with multiple arguments. Okay? So if we have functions that take in multiple arguments, let's say they take two numbers and add them together, we can also use that in apply and give that function two columns instead of one to apply on. Okay? So I'm going to explain with a demo. And I'm also going to show that if you call apply and you don't pass it any column labels, you get a row as your argument into each function. Let's talk about it. Let's see if I can log on. Well, that's unfortunate. Aha, it works for me. Okay, hopefully it works for you too. So if you recall from yesterday, we were looking at Galton's data. All right. So again, Galton was looking at children, and he was looking at the heights of their mothers and fathers. Okay, so here's one kid, or really not a kid anymore at this point. He was measuring them when they were like fully grown. So there's one, I guess, young adult, and mother and father heights. Okay, so we have that. If you'll remember, we were looking at the mid-parent height and seeing how that compared to the child's height. Okay, so we made this scatter plot. So let's select. So I'm just going to recreate the table that we did yesterday. Parent. And relabel one child. So I'm just going to grab out these two columns, just like we did yesterday, and rename the columns. That's about it. So I'm going to call this heights, and heights scatter. Let's just show you what it looks like. So again, we have this familiar looking scatter plot. Mid-parent height on the x-axis, child height on the y-axis. See like this kind of upward sloping trend. Okay. So what I'm going to do is take a look at the first row of Galton's table. If you remember the row method takes in a row number. So all the rows are numbered from 0 to however many rows there are. Galton.row0 grabs the first row of the table. Okay? And with that row, I can grab the item. Let's say I want to take a look at the father's height. So this is item number 01, so item number 1. And I get back the father's height. I'm just going to do it down here so you can kind of see everything. Let's do that, oops, that, and then that. So I take the first item, or item number 1, sorry, not the first item number 1 out of this row, so 78.5. Cool. Now, let's suppose that I want to, so another way we can grab stuff out of rows is instead of saying item number 1, I can just say item father, the column name, and that'll also give me 78.5. Okay, so that's another way to do that thing. If I ask for the length of the row, this will return back, darn it, length of Galton.row. If I ask for the length of the row, this will give me back 8, because there are 8 columns in that row, 8 columns in that table, and so the length of row is 8. Okay. Oops. Okay, so let's do that. And what I'm going to do is I'm going to try to recreate the mid-parent height. Okay, so the mid-parent height in theory is the father's height plus the mother's height divided by 2. That gives back the mid-parent height. So let's see if I can recreate that just for the first row of my table. Okay, so I'm going to take this number here, add to this number, divide by 2. I'm going to do it using row operations so you can kind of get used to seeing me do that. Okay, so here we go. I'm going to call this M. And I'm going to use the first row, so let's call that first. So I have my first row. M equals first item mother. And here I have F equals first item father. So I'm grabbing out the 2 numbers in that row. And then I'm just going to take mother plus father divided by 2. And I get 72.75. Let me go back to my table and compare. And it's not 72.75, it's 75.43. What did I do wrong? Well, it turns out I didn't do anything wrong. Actually, when Galton made his table, he actually said the mother's weight was a little bit more important than the father's weight, by about like 8%-ish. Why did he do that? The real reason is perhaps a mystery, although it was suggested at the time. It was said at the time, like measuring the mother's height is a little bit more trustworthy than measuring the father's height, because chances are, if you went to someone's house and you measure the mother's height, you're more likely than not getting the biological mother of the child. Whereas if you went and measured the father's height, well, who knows who that could be. So they thought the mother's height was more trustworthy than the father's height. Anyway, this is just what Galton did in his data. So at the time, he was like, this is the way I want to do it. So that's how he did it. So if you do 1.08 times the mother's height, you get 75.43. Go back and double check, 75.43. So that's actually how Galton did his data. Okay, so he did that, mother plus father divided by 2. Okay, so let's suppose I want to do the same thing for the second row of the table. I need to do something like Galton.row1, item mother, Galton.row1, item father, and I get the second thing. The second thing is the same as the first thing because these are all the same family, so they have the same mother and father. Let's skip down to like row number 4 and try to see if we can get 73.66. So row number 4, like that, okay? 73.66. Okay, so what I've done here is I've just copied and pasted my code, changed the stuff I need to change. And I look at this and I'm like, well, seems like I'm repeating myself a lot. Let's write a function to do the same thing. Okay, so let's find a function called midparent. And I'm just going to say this will get called with 2 arguments instead of 1. And I'm going to return. So I'm going to get passed in the mother's height and the father's height, 2 arguments. And then I'm going to return that. Okay. So now when I call midparent, this is just what I did before in function form, which means that I can call midparent and pass in first item mother. Well, let's take the row. So let's do that. Mother, and the 4th row father, and I get 73.66. Okay, so the same as before. Any questions about that? Cool. So I promised that I was going to use apply. Let's do it. Okay, so I have Galton. And I want to recreate this midparent height array right here. So I'm going to first take off the first 10 rows just so you can kind of see, just so you don't get a whole lot of numbers at once. So just the first 10 rows of that table. So I got .take. And then I'm going to apply midparent. And midparent, I want to apply this function on both the father column and the mother column. Okay? So before, when we're looking at apply with only 1 argument, what would happen is when I call apply, it calls midparent. Let's say midparent. So let's say we're using apply as before. If I call it with just father, as we did yesterday, when I call midparent, what Python's going to do is it's going to go through every single value in this column right here and call midparent on it. So it's going to call midparent 78.5, make that the first element. Then it's going to go here, call it 78.5, make that the second element. And then I'm going to go down to here, 75.5, call that on 75.5, make that the next element. So it's going to build an array, 1 element for every element in my original table. And it's going to fill in that array with the value of calling my function on that element. If, on the other hand, I pass in 1 more column, father and mother, what Python is going to do is it'll go through both columns at the same time. Okay, so it's going to go through both father and mother. It's going to say, OK, give midparent 78.5 and 67. Okay, then go through and call it again, 78.5, 67, and then call it again, 75.5 and 66.5. Right, so 75.5, 66.5. And it's going to go through and call that once per row in my table. And what I'm going to get out is the array containing different values called once for each value in my table. Okay, so I define my function, and then I've called it and gone back a new array, the same height as my table, 1 element per row in my table. Any questions about that? Strange, there are no questions. Yes, Robert. Oh, oops. Robert says, you're right, I totally misspelled that. Father, my bad. There you go. Those numbers are more like it. Thanks for the catch, Galton. Just to check, 75.43, 75.43. Excellent. Did you have a question, Sean? Yes.
Where did
where did the father go to? So you're saying I only got one number out of my, I only got one number for each thing. Is that your question? So Sean's question is, well, if my function takes in 2 arguments, what happens to my second argument? Like why do I only get one number out? And that's because any function you give into apply needs to take in some number of arguments, but can only return back one argument, like one value, one return value. Okay. So in this case, I'm not exactly like returning both mother and father. What I'm doing is combining them together in some way into one final result. Okay. So my function here takes in 2 inputs and has 1 output. The 2 inputs are 2 numbers, and the output is a single number. So 2 inputs, 1 output. So when I pass it into apply will give it the 2 inputs, the mother height and the father height, and then it will get back out the single number output of that function. Good question. Okay. So now that we're working with these functions in more detail, you really have to be clear. First, you need to know what type of thing your function takes in. Okay. So be clear about types. This function takes in 2 numbers and returns back another number. You really need to make sure you understand very clearly which types of stuff is incoming and outgoing, because if you don't, no matter how hard you work on your function, you're going to get it wrong. Okay, so first, you have to make sure you get the types correct. Okay, so it was simpler before in another time when we only had numbers and maybe strings every once in a while. Now we have numbers, strings, arrays, tables, and functions. Okay, so you really need to nail down the types of things. Then for a function, you want to make sure how many arguments it takes in and what it spits out. Okay, what type of thing it comes out of the function. Functions generally only have 1 return value. So you don't really have to worry about how much stuff comes out of the function, but you need to worry about what type comes out of the function. Okay. Cool. So that's apply with multiple arguments. And that's that. So I want to move on to a very cool topic and also potentially confusing topic in this class. So that was hard topic number 1. This is hard topic number 2. We have more hard topics coming. Have a good Friday. Okay, so grouping rows. So group. Oftentimes we want to oftentimes you have a table, and that table has a column, and that column has like categories for that particular item. For example, when we're looking at movies, we saw that each row had a studio that it belonged to, right? When we're looking at the NBA table, every row had a team. So each player had a team that he belonged to in the NBA, okay? When we have a table with that kind of structure, when the column contains those kinds of values, it makes sense to say, oh, okay, so we have a bunch of players. Each player belongs to a team. What team makes the most money, or what team spends the most on its point guards? In the case of the studio, which studio released the most movies? So instead of looking at the table in a row-by-row format, we're asking questions about the categories in the table. When we ask questions about the categories in the table, we want to use the method group. Okay? So the group method aggregates all rows with the same value for a column into a single row for the results. This is how to call it, but I think you'll understand more if I show you how it works. Okay? But we saw a group when we first saw a group when we were working with the studios, the movies. If you remember, we did movies.group. And we did group on the studio, and we got back 1 row for every studio. And the second column, we had how many movies that studio released, right? So we had 1 row for every studio. Disney released 42 movies. Fox released 15 movies. We had that kind of table, okay? It turns out that you can also do more things with grouping. So not only can you count the number of times each movie appears, you can also do stuff like how much total gross did each studio produce. You can do more things within that group, because what you're doing is you're looking at the categories and then grouping together each category and doing something with that aggregation. Okay, so for example, we can compute the number of grouped values, such as the number of movies each studio released, or the total of all grouped values, so that the total amount each movie made. Or we can do a list of grouped values. I'm just going to show you what I mean, because this slide is not super clear. Okay, so let me show you. Okay. So what I'm going to do is I'm going to use group. Okay. I'm going to use a totally made-up data set called cones, just to show you kind of what's going on. It's pretty simple. It has 5 rows, Every row has a flavor of ice cream and how much the ice cream costs. Okay, so I'm going to run that. And we have here strawberry $3.55, and here we have some really expensive chocolate ice cream for $5 a scoop. Okay, so ice cream. Now, what I can do is I can group. So let's say I want to group by flavor. Cones got group. So I call a group method and pass in the column I want to group on. And flavor, sorry, capital F. There we go. So what do I get back? What Python did was it went through this flavor column and grabbed every single unique value in that column. So it said, OK, here's strawberry, here's chocolate, chocolate again, it's a repeat, strawberry again, it's a repeat, chocolate again, it's a repeat. So what it did was it grouped each category together. So it said, OK, all the strawberries, all the chocolates, and then it says, what do you want me to do with that group? By default, it just counts how many items are there in each group. So there are 3 chocolate items, I get a count of 3. There are 2 strawberry flavors, I get a count of 2. Okay. But I can do a little bit more with that. So I can say, let's group by flavor, but let me compute the sum of each flavor's prices. So what happened in this case? So again, Python goes through and says, OK, I have 2 strawberry guys, 3 chocolate guys, and now I have this other column called price. What do you want me to do with that other column of price? I told Python, I want you to sum it up, which means that it will take the strawberries, which is in one group, and sum up their prices. Okay? So it will say, OK, 55 plus 525 is 8.8. And then it look at my chocolates. Chocolates have these prices. It takes those prices and sums them up. Now I have, for each flavor, the total sum of the prices. Okay. Any questions about that? Yes? Yeah, so Henry asked, if I have more than 2 columns in my table, how does Python know which column to sum? It will actually try to sum them all. Okay, so, which is sometimes not the smartest thing to do, but let's suppose that, let's see, I did something like, I don't know, with column, number of amounts of sugar. OK, so let's take sugar, make array. Let's say strawberry has like 10 sugar. This kind of chocolate has 20. Maybe this kind has 30. This kind has 15. I have another one with 20. So let's say I have this table, another column here. If I call a group flavor and tell it to sum again, what we're going to get is not only the price gets summed, but the amount of sugar also gets summed. Okay, so every other column besides the one you're grouping on will get summed if I pass in sum. Now, it's not necessarily always the case that you want to do that, because if I had something like Sam likes this flavor, Sam also likes that flavor, Sam doesn't like that flavor, right? And I do that and I try to sum, what I'm going to get is not something that quite works out. So it's not actually going to error, but it's just going to leave it blank because Python's like, I can't do that. Okay. Good question. Okay, so let me just move that down here so you can kind of see that. Oops, let's do that. Well, I have a lot of these guys. That, OK. So let me undo that. Okay. Cool. So just to recap, or just to kind of make clear what I'm doing here, I can do the same thing using where. Okay, so I don't have to use group to do this, although it's more convenient. If I did where, I could first do where flavor is equal to chocolate, grab those rows, and then say, OK, I want to take the column price, right? And then I can take the sum of that and get my 15.25. And I can do the same thing for where flavor is strawberry. Sum that. So I get 8.8. There's a rounding error here, but 8.8. I have these two things. I could have made a table myself by putting those into an array and then making it a new table. It's a huge pain to do that. So group is typically the way you want to do this. Okay, so if you find yourself like having to go through the table and select out each category and doing something with each category, typically that means you want to use group. Cool. Oops. All right. So I know I can do something else besides sum. So let's take flavor. So let me show you the cones table again. So I have flavor and price. Let's say I group by flavor again, but I pass in a different function instead of sum. I don't use sum, I use max. What will I get from max? What do you think? Talk to your neighbor about what you think will happen. Okay. Anyone have any opinions on? Anyone have any guesses on what they think will happen here? Kevin?
Take all the prices of each unique item and take the maximum of it.
Right. So Kevin says, I'm going to go through, take my strawberry items, and take the maximum price. Go through my chocolate items, take the maximum price. That is absolutely correct. So I should get strawberry with 5.25 because that's the highest price, and then chocolate with 5.25 with the highest price. Okay, so 5.25, 5.25 price max. Cool. Okay, so I can put in any function I want here. So I can do np.mean. Now I have the average price for each flavor. Here's the max price for each flavor. Here's the total price for each flavor. Okay, so I can do any function I want here, and group will be OK with it. Okay. Now, what type of thing does this function need to take in? You should be pretty clear about what types of things this function takes in. When this function gets called, it will get called with an array. Okay, because when Python goes through and puts together all the chocolate elements, it will say, OK, I have 3.55, 5.25. Let me put that into an array. And then I will give that array to the function that you give me. Okay, so when I call np.mean, the first time I call np.mean on strawberry, or let's say on chocolate, I'm going to get np.mean on the array of 4.75, 5.25, and 5.25. So it's going to get those three elements as an array. And then it's going to get called again on strawberry. It's going to get these two elements as an array. So this function right here needs to take in an array, and it needs to return out a single thing. Okay? Any questions about that? Very well. That means that you can actually define your own functions. I won't go into that today, but if you define a function that takes in an array and returns out a single value, you're going to also pass it into group, and that gives you a lot of flexibility over grouping and finding out how things differ by categories and all of that stuff. Okay? So just to recap, I have, let's see. So this is how the group method works. And you saw here I can use len and sum and list. If I use list, what happens is this is a special method that just takes an array and gives me back a list with the same things in it. So if you use list, you actually just get back the list of the numbers for each group. I didn't do that today, but you can try it out on your own time and see how it works. Okay. Let's do attendance. All right, gonna open it up. And let's collect. OK. Excellent. All right. So go ahead and do that. How many guys are in row A? Row A, raise your hand. Row E, raise your hand. Row E, OK. Row I. Great, my eyes. Excellent. All right, so while you do that, let me go ahead and use group an example using real data. Okay, so here I have the NBA table that we've looked at before. One row for every player, position, team, salary. Okay. What I can use using group is ask the question, let's say which teams spend the most on their players. Okay. I can do that by grouping on the team column because I have a bunch of teams and I want to find out how much each team spends on its players. So I can do nba.group team. And if I do that, then I get a team and how many rows a team has in this table. Well, it's not super helpful to me. I want to find out the salary. So let's see if I can take the sum. If I take the sum, I'm going to take the sum of every other column besides the team column, which means that Python is going to try to take the sum of players, the sum of positions, which doesn't make any sense, so these are blank, and then the sum of salaries, which is actually the thing that I want. Okay? So typically when I do that, when I notice this happening, I want to do select before I do the group so I don't get these weird random blank columns. So I'm going to select out team, salary, and now I have just the team and the salary. I see here that the Cavaliers spend a whole lot of money and the Brooklyn Nets not so much. Okay? So I can take this table and I can plot it. Okay? So let me bar H on the team. This will produce a big table with every team in the NBA. It just lets me visualize the salary, like the sum of the salaries for every team. It will take its sweet, sweet time. Maybe it takes too much time. Stop it. Uh-oh. Come on. Uh-oh. It got stuck. The NBA is too good for my notebook. All right, well, in this case, let me try this one more time. Kernel, interrupt. Come on, stop it. It didn't work. OK, so what I'm going to do is I'm going to restart. If I restart my notebook, it'll... Oh, no, it broke for everyone. Oh, no. Well, let's find out. Nothing is going right on this Friday. I see. Very well. Let's continue onward. I'll use my own computer. Let me make a new notebook. Great. Let's see. Did this refresh? This looks like it refreshed. Look, it worked. Why is this not working? Let me try to restart. If I restart, it will forcefully just kill whatever's running right now, and I have to go back and rerun everything and get back my variables. So I'm just going to rerun this to get back my data science library, and I'm going to run this to get back the NBA table. There we go. Now I can select. Okay, so maybe I shouldn't have bar H the whole thing. Maybe I can take out the top 10 rows, 10, and then bar H those. Cool, so that worked. I have here the 10 teams that appear first in my table and how much they spent on each player. Maybe I want to find out which teams spent the most, so like the top 10 spending teams. So before I take the top 10, I can sort it. So I can sort by, this is getting really long. When it gets long like this, I can use parentheses and just put each of these guys on a new line. So sort, take, bar H team. I can sort by the salary, or I believe it's column number 2. Descending equals true. And if I do that, nope, sorry, there's only 2 columns. I see that I have the Cleveland Cavaliers, OKC, Golden State Warriors, blah, blah, blah. So Golden State Warriors, Thunder, and Cavaliers spent the most on their players. Okay. So I can also take a look at, so again, look at my table, look at what categories I have available. I have the team as a category, but I also have the position. So I can group by the position, and what can I get out of that? I can get what positions were the most expensive. I can get which positions were paid the least. I can get which positions made the most on average. Okay, so I can do all of that with grouping. So I can group by position. So NBA, I want to group by position. Again, if I don't pass in anything, I just get how many there were. So it looks like there were less centers than everyone else for some reason. Group by position, and then I can also do the sum. I do the sum. Again, I get these blank columns, but here's the salary. So it looks like total overall, small forwards made the most overall. And if I take the mean, I get back which position is tending to make the most overall. So here is centers made the most on average. Okay, so grouping, I can look at different categories that are available in my columns. Any questions about this? Yes, in the back. Sorry?
Is it possible to just select the row that you want the function on, or do you have to run it on every?
So is it possible?
Sorry,
Column. Is it possible to not to run on every column? Yes, it is. But before you do group, you have to do .select. If you do select before, then you don't get these blank columns. Good question. OK, so let's talk about, is anyone not done doing attendance? Cool. Turning it off. Donezo. OK. Now let me talk about grouping by 2 columns. So if grouping by 1 column wasn't confusing enough, now I'm going to group by multiple columns. So instead of grouping and looking through every column and grabbing each value out of that column, I can look through 2 columns and grab all the unique pairs of values in those 2 columns. Okay, so when I do a group, I can also pass in more arguments into group. So here, I can give it, instead of a single column, I can give it a list or an array of which columns to group by. Okay? Let's see how that works. So I have group. Let's take my NBA table. Actually, let's do a simple example first. So I have all cones. Sorry, cones. Cones. Right, I have to grab it. It got erased. Where's my cones? Cones. OK. Now I have all cones. All cones. Here's my cones. OK, so let's call this group multiple columns. I have all cones. And you'll notice that each flavor, each ice cream not only has a flavor, but it also has a color. Here's strawberry flavored pink ice cream. And here is bubblegum flavored pink ice cream. Sounds kind of nasty, but it's there. So we have here these guys. And if I use group, I can group as usual. So if I group on the flavor, this is what we've seen before. So I get how many bubblegum, how many strawberry, how much chocolate, how much strawberry there are. Okay. But if I pass in an array, so let's say I do make array, and I pass in flavor and color, close my parentheses, what do I get back here? I get back 1 row for every unique pair in my table of flavor and color, right? So bubblegum and pink occurred only once. Chocolate and dark brown occurred 2 times. So here's my 2 chocolate dark browns. The chocolate and a light brown only appeared once. And strawberry and pink appeared 2 times. Okay? So instead of looking at just my flavor column by itself and grabbing the unique groups out of that, I look through 2 columns at once, grab the unique groups using those 2 columns, which means that every unique pair will end up in my final table. Okay? Now, why might this be useful? Well, let's say that I want to look at the most expensive, just for instance, dark brown chocolates. So now I can see that my dark brown chocolates had a total price more than my light brown chocolate ice creams. This is not super useful, but you kind of get the sense of what I can do here. I can also pass in any function I want, np.mean. I have like the average price. It looks like dark brown chocolate is on average more expensive than like strawberry and pink ice cream. Okay, so do stuff like that. But now let's look at the NBA table. So this is real data again. NBA. Okay, and let's suppose that I want to find on each team the most expensive player for each position. Okay, so I have a bunch of NBA teams. Each team has 5 positions, so like point guard, I don't know positions that well, point guard, center, small forward, shooting guard, all the 5. Let's say that I want to find the most expensive players for every team and position. How would I do that? Talk it over with your neighbor. My question was, every team has every row has a team and a position. What are the 5? So I want to know for every team and the 5 positions available, who are the most expensive players? So for example, it looks like Paul Millsap got paid a lot as a power forward for the Atlanta Hawks, but there were probably, so it looks like Mike Scott did not get paid as much as a power forward for the Atlanta Hawks. So I would want Paul Millsap over Mike Scott. Yeah. So I want 1 row for every team and position, so 5 rows. So basically, every team should appear 5 times for each of the 5 positions, and I want each of those in sequence. Okay. Okay, so to do that, let's see if you're on the right track. We're talking about grouping, so we can group. I want to group on both the team and the position. So if I do that, then I see one row for Atlanta Hawks for every position. So it's all these 5 positions, and then here come the Celtics, 5 positions. If I keep going on the table, I get more teams and position pairs. Instead of counting up how many players there were for each position, I want to find out the max player. So the maximum salary paid to each position. Unfortunately, it looks like, so if you look at this player max here, this is actually like the alphabetical max of each player. So it's actually not helpful at all and kind of misleading, to be honest. So as always, before a group, I'm going to do is .select, grab out my team and position and my salary. Grab those out. Now I just get back, okay, it looks like the power forward on Atlanta Hawks made a lot more than the small forward and a lot more than the shooting guard. Okay, yeah, question?
Is there any way we could get it to also pull corresponding player's name?
Yeah, so is there a way we can also pull the corresponding player's name? I'm actually leaving that as an exercise for you. So I'm going to pose a question at the end of lecture for this first half, asking you to get back the names. For now, just know that group can get back the salaries, which is something. But if you want to get the names to do a little bit more work, it's a little complicated. But maybe if you work at it hard enough, you can figure it out. OK, so I have here the select, I have the group. OK, so I'm going to call these guys kind of like, let's see. I want to call these like the starters, because I'm going to assume that in every team, the 5 players that make the most money in every position are like the starting lineup, the starting 5 that play when the game first starts. OK, so I have my starters here. Starters. Let's suppose I want to find out which team pays the most money to its starters. How do I find that? Talk that over with your neighbor. Yeah. Sorry, my question was, which team pays the most money to its starting 5? So do the Atlanta Hawks pay them? So right here, the Atlanta Hawks pay like this much money to the starting 5. The Boston Celtics pay this much money to the starting 5. I want to find out which team pays the most overall to the starting lineup. All right, so to find out how much each team pays to the starting 5, I can take my table starters, and I can group again. Group by the team. What will that do? It will take each team and make one group for every team. It will take these 5 numbers and put them into my group. So I can take the sum of those numbers to get back the total amount paid to a starting 5. Okay, so let's say here the Atlanta Hawks paid $48 million, Boston Celtics paid $25 million. The position here is not super useful, so again, I'm going to drop it. Select. I can just drop position. Group. So now I have this, and I can figure out which teams made the most by sorting by column number 1, descending equals true. And I spelled it wrong, descending equals true. So now I see that, again, the Cleveland Cavaliers pay the most to its starting 5. Let's make a bar chart. So this is getting long. Again, parentheses in the beginning, parentheses in the end. I can do new lines here. And I can sort, or I can take the top 10, and I can bar H them. Bar H on team. So let's see here, Cleveland Cavaliers made a lot, or paid their guys a lot. The Golden State Warriors kind of fall down to the bottom here. It looks like that might be because they paid a bench. They paid a bench a lot as well, and the starting players not as much. Cool. Any questions about that? So lots of grouping. Basically, anytime you have a category, you can use grouping and do some stuff within that category for each group. Okay. So that's what I want you to take away from this. All right. So here is a question that was posed earlier, which is, oh wait, we already did this. Okay, we did this. All right. So let's go here. I'm gonna skip there and then show you the take-home question. So my challenge question to you is find out who were the starters. Okay, so find out for every team, the center, power forward, point guard, shooting guard, who were the 5 starting players for every team. It looks like for some strange reason we're like missing this data or something, so it's blank. But the 5 players for every position who made the most money for every team. So see if you can figure that out on your own time. I'm going to talk about pivot now. So it turns out that when we're looking at groups and we're grouping 2 columns together, so for example, if I group here, this kind of table, it seems like it kind of makes sense to look at it as kind of a grid of two different categories, right? I have my team as, I have my team on one hand and my position on the other hand. If you imagine with me for a second that if I had a grid of like Atlanta Hawks, Boston Celtics, Golden State Warriors, and I had on the top, I had like the 5 positions, then I had like a 2-dimensional grid of the salary maxes here. So maybe this data can be better visualized using a 2-dimensional grid instead of like this really long table here, which I can't really see. Okay? So to make a grid like that, I can use a method called pivot. What pivot does is it's essentially doing group using 2 variables, using 2 columns, as we discussed before. But instead of leaving the table as a long list of like different categories, what it will do is it'll take one category and put it on top so that we get a 2-dimensional grid of results. Okay? So cross-classified produces a grid. The first argument to pivot becomes like the top labels of that grid. The second argument to pivot becomes the row labels of that grid. Okay? So the 2 optional arguments, I'm just going to show you how it works, so that perhaps you guys will get a better idea by looking at my examples. Okay? So let's take a look at my cones. So I have here my cones table, all cones. Let me call this section pivot. Okay. If I pivot on flavor and color, so first I'm going to group, just show you how that works. So group, make array on flavor and color. This is what we've done before. I get back the individual flavor and color pairs. Okay. So instead of grouping like this, I can use pivot to make a grid. Pivot on flavor and color. And what I get here is you'll notice that the 3 different flavors go on top, and the 3 different colors go on the side here. And I get here a grid counting out how many of each pair there were. So same information presented in a different way. Sometimes you'll find this more like easy to look at than this one. Yeah, Kevin? That's right. So this is actually a table. It returns back a new table here. Unfortunately, the table is not super easy to work with. It's usually used for kind of like just displaying the data. So it's not particularly easy to work with this data because you have to like select the column and then you have to do .where to get back the row that you want. But it is useful for kind of looking at a glance where your data kind of lie in this grid. Okay. So you can think of it as like kind of a visualization, but not really. So that's what pivot is useful for. Okay, so I got flavor and color. Now, if you remember from before, I also did something like this, where I wanted to look at the sum of the prices for every flavor and color pair. I can do the same thing with pivot. So if I take my all cones table, I have flavor, color, and price. the way to use pivot and do this is to say, OK, put my flavors on top, put my colors as rows, and I want you to take the values in price and sum them up. And that's how you tell pivot how to do that. And values. And didn't work. Flavor, color, yes, indeed. There you go. Okay, so we have here a similar kind of deal. So this corresponds to this, just as this corresponded to that. I have here flavors, colors here, and price sums for each one. Okay, so pivot will not sum up all the other rows of my table like group does. I have to say explicitly which column I want to do the sum of if I want to do a pivot table that way. Okay? Yes, Kevin?
So what do values and collect do again?
So values here says which column do you want me to kind of group together, and collect says what function do you want me to call on those values. Okay? So value says so here I've said put my flavors on top, put my colors as the rows, and then take my price column. So if I had more columns here, this tells Python take only the price and none of the other columns. And then for every group, find the sum of each group. Okay, so just like I did before, but now it's in a two-dimensional grid form. That's it. Cool. So let me run through a couple more examples with the NBA table. So if I take my NBA table, and I want to group by position and team like I did before. So group by, let's say, team position and team. Oops, I didn't make this an array. Make array. Let's do that. So you see here positions and then teams. Okay. So instead of doing group, I can just do pivot. So I can see more at once. And if I do that, then I see, OK, positions on top, teams on the side. Atlanta Hawks had 3 centers, 2 power forwards. And it looks like the Detroit Pistons had no power forwards, confusingly enough. We're probably missing some data there. Okay, so with a pivot, we get this table. And again, I can pass in values equals salary and look at the total amount of salary paid for every position by every team. Collect equals sum. Okay, so here I have Atlanta Hawks paid the centers a total of 22 million, and their small forwards only 6 million. Okay. Any questions about that? Yes, name and question. Andy. Sorry, I couldn't hear what she said over the screaming drill outside. What if the function that we pass in here, so Andy's asking what happens if this function has more than one argument? It'll probably break. This function here has to take in a single array as an argument and output out a single value as its return value. Otherwise, bad things will happen. Cool. So let's go back. So here's my take-home question. All right, so we're kind of done with the hard content for today. Everyone applaud yourselves for getting through. Woohoo, you guys made it to like the 3 hardest topics in the class so far. So we've gone through apply with multiple columns, group with 1 column and multiple columns, and pivot. Okay, so a lot of stuff to go through. Just take your time. Okay, so take your time. Don't worry if it just like kind of flew over your head during lecture. Take your time, like practice with it. Go through my lecture again. Go through a textbook. Like do some practice. After a while of working with it, you'll get a sense of like, OK, I can use group for this. I can use pivot for this. It'll take a lot of time and practice for you to really get a grip on these things, especially if they're new to you. Okay, so take your time going through this. Don't worry too much that this table is really intimidating and you have no idea how to make it. Okay? But do take your time and do try it out. It's quite challenging. You'll have to define your own function and pass that into group. OK, cool. So now is time for our education idea of the week. This man right here is named Claude Steele. If the name sounds familiar to you, it's probably because you've seen some of his emails. He was the vice chancellor of UC Berkeley for a while until maybe about last year. Now he's a professor in the psych department, which I am very pleased about because that means he's going to do more psych research like the one that he did before. So his research was on this idea called stereotype threat. In fact, he coined the term stereotype threat. Have any of you guys heard about stereotype threat? A couple of you guys, nice, nice. So basically what his experiment was, he was interested in knowing whether feeling like you were stereotyped affected your performance. Okay, it's a simple question. And what he did was he gave college students like the written portion of the GRE, so like the exam to get into grad school. He gave like sophomores in college this exam because he wanted it to be hard for these people. Okay, so sophomores in college taking the written portion of GRE, it's probably like above like what they know at the moment, so it's hard for them. And he had European American students come in and African American students come in one at a time, and he had like a couple different groups there, but the two more important ones were, what he did was he was like, okay, it seems like a stereotype is that African American students are not as intelligent or don't do as well in school. Let's see if that actually plays out in their performance on the exam. So as students came in to one group, he said, so both African American students came in and then European American students came in. They kind of came in one at a time. For one group, he said, this test is a measure of your intelligence. So go ahead and take this test. It's used as like kind of we'll use it as a gauge to measure how intelligent you are, how good at school you are. To the other group, he said, this test is just experimental. It's just meant for us to kind of like diagnose where you are, but it's not in any way a measure of your intelligence. Okay, so that's the only difference between the two procedures that he did for these two groups. And what he found was that, so there is actually a lot of research being done on kind of like the performance gap between different races in like schools and all of that. And the research that had kind of gone on at the time was saying, okay, it looks like African American students and minorities tend to do maybe like, I'm not exactly sure the exact number, but about like a letter grade worse than everyone else on like math, English, on most school subjects. Okay, and what he found was on that GRE, when he said this test is a measure of your intelligence, he found that achievement gap was still there. So African American students, in his case, did about like a letter grade or like one like level worse on average than the European American students. However, in his group where he said this test is not a measure of intelligence, but it's just an experiment, what he found was that achievement gap had actually like closed itself. There was no actual gap between African American students and European American students. And so he said, well, this is kind of strange. It seems like even just suggesting or even just bringing up the idea of a stereotype makes you do worse. And people have gone on to do more research on why that's the case, like biologically, psychologically. But he was very famous for this idea, and it sparked like a whole lot of research in this field of stereotype and all of that stuff. And so I kind of wanted to get you thinking about that because, darn it, I was supposed to review these one at a time, but now these are all at once. Okay, so again, stereotype threat is kind of like the feeling that if you feel like, or even if you even have the suggestion that you're being negatively stereotyped, chances are that it'll affect your performance or mentality or like mindset in some way, and usually in a negative way, because a lot of stereotypes are negative. Even if that stereotype is not explicitly stated. So he never said, oh, you're black, so you're going to do worse in this test, right? He just said this test is a measure of your intelligence. And just that word intelligence, because it's associated with the stereotype that people had, made them do worse. Over a long period of time, like this stereotype threat can lead people to disidentify themselves with groups. So people have replicated this research across many different groups, many different stereotypes. One specific instance was looking at females in math. Okay? And what they found was that when females are doing math, the stereotype there is that girls are not as good in math. And what they found was over time, a lot of girls said stuff like, I am not a math person. So they kind of like distanced themselves from that identity of like being a math person or being good at math. Okay. This can have long-term mental effects. They've done a lot of research on this, like, and linking this to depression, all of that. And so there's a lot of like so basically it's a bad thing. And it's a bad thing particularly because it's kind of subtle, right? You might not notice it. Even if you're being affected by it, you might not notice it. And even if you're not being affected by it, you might be propagating it in a way that you don't realize, just by kind of like being insensitive to what stereotypes people are kind of putting themselves under or being put under, okay? And that's why I mentioned this during class, because in this class we tend to get a pretty diverse range of students. people come in with all sorts of like premonitions or like preconceptions about like how well they'll do in the class, whether they're like worthy of taking this class, whether like they're falling behind too far. And again, I want to reiterate that this class was meant for the newcomer. Okay? So this class was meant for people who did not have a background in CS, who do not have a background in stats. We're about to do some pretty hard stats stuff in the next coming weeks. I hope you prepared your minds. But we're going to go through some pretty tricky concepts in this class. But we've tried to tailor this class in a way where you can definitely learn it. If you kind of like take what you have and kind of like build on the knowledge that you have previously step by step, we believe that everyone who takes this class can learn this material very well. And that's kind of our hope for this class. Okay? And that's why I say it's a cooperative effort to address, because we need to be aware of what's going on in like our wording and the way that we kind of frame different things to each other. Okay? So if you'd like to read more about it, here's a link. You can look at my slides. And we're going to take a 5-minute break. I want you to ask, have you or a friend ever experienced stereotype threat? Talk about it with your neighbor and then take a 5-minute break. We'll go ahead and get started again at 11:21. 11:21.
I was trying to do the, sorry, I can't think of the word. The attendance form, the excuse form. Attendance excuse form.
Oh yeah, it looks like I did not create that properly. I'll fix it and let you guys know. Yeah, sorry about that.